to the Bytecode. I'm your host Shafu, and today's episode is with Tamara, who's going to walk us through Alkimiya. Tamara, thanks for taking the time.
Thank you. It's a pleasure to be here.
Awesome. Yeah, if you could maybe introduce yourself shortly and introduce Alkimiya, and then we can directly jump in the code.
Sure. So I'm Tamara Rengus. I'm a Solidity developer. I also do some indexing and backend work. And I worked, on Alkimiya, which is a block space market infrastructure. So you can trade and hedge block space resources. So things like ETH gas, or our newest product is Bitcoin transaction fees. And we're on version 3. I'm wearing a hoodie, so this is our logo. Um, and it's an hourglass with sand going through, and I'll explain why in a bit. This is
Nice.
the website here. If you go to alkimiya.io, this is the homepage. So so you can hedge and trade and speculate. So you can go short or long. So if I think Bitcoin transaction fees are going to rise within a certain period, and those periods are fixed, like usually a week or two. If I think they're going to rise, then I'll go long, or I can go short on transaction fees. So I'll just show you some information on the site. So what we're doing is Satoshis per virtual block. So that's the fee to get a transaction included on the Bitcoin network. This is just like it's average recently. And then this is just explaining how you can go short or long if you think transaction fees are going to change, and how you think they're going to change. Rollups are a big user, because our next thing is ETH base fee, and then they pay a lot of gas, so they can lock in gas at a certain price and then do their transactions. And then if the price increases, they'll make money, and if it decreases, at least they have saved it. And then we've got some resources and blog posts down here. And here's what the site looks like. My wallet isn't connected currently. So this pool is from the 2nd of August to the 3rd of August. So it's just a 1-day pool. And this is what the transaction fees have been doing in the last 24 hours. So I think I would long here because it looks like it's going down. So I'd probably long. The cap is the highest point where where the oracles think the pool will go. And then the floor is the lowest, which is 1 now. And then you can create an order. Buy is a long order, sell is a short. And if there were orders, they would show up here. And then my orders would be here. And when my orders are filled, they become positions. I'll explain that when we go to the contracts. And if you are going to use this app, I highly recommend going to the data page, which is a Dune dashboard of the 7-day moving average and the 30-day moving average. So you can see here a more accurate representation of what the median transaction fee has actually been doing in the last while. It's quite there's a lot of information here. I thought maybe I'd start with the docs to explain just an introduction of what it really is. So, like I said, you can create, trade, and settle synthetic block space resources, and that's done through the smart contracts. These are just people who might want to use and the benefits of trading Bitcoin transaction fees. This is our current product. Some really cool designs by our designer Charmaine. And here's the architecture overview. So we have 2 main contracts, and each time we'll add a new asset. So let's say base fee, then there'll be an extra Oracle contract for that asset, that underlying block space resource asset. So the main thing is a silica pool, which comes back to the logo. The silica is like time moving through, like sand moving through an hourglass. So a pool is all the positions and shorts and longs within a certain duration with a set cap and floor. And then this is the index. So this one will be the index for Bitcoin transaction fees. It's a smart contract that then this pulls from. And we have a off-chain oracle that calculates all the Bitcoin transaction fees and feeds it to the Silica index. The Silica pools then reads from that. We have Creeper bots, which are cron jobs that start and end the pools when their start and end dates are, which we usually schedule at UTC 0, so midnight UTC. Then there's the UI and an off-chain backend order book service, which uses GraphQL. Yeah, it's on Ethereum mainnet. We launched like a week or two ago. So here's all the addresses for the testnet and mainnet. For the testnet, we made our own test WBTC, but on mainnet you use actual wrap Bitcoin. That's why there's only two there. We got two independent auditors, and then we also did an audit with Zelic, which can be found here. Quite an interesting report. I really liked working with Zelic, I must say. And yeah, these are just some key concepts. The index is that Oracle contract. Silica pool is the set of all long and short positions. Pardon? Yeah.
Oracles. What about oracles? Like, what oracles are you using for this?
Pardon?
Which oracles are you using for this? Like, how do you settle this?
It's a centralized, it's a oracle we made, and it does an RPC call to the Bitcoin network every hour, and then calculates the median transaction fee from those, and then adds that up for a day median transaction fee.
Okay.
And then we also have an SDK, which I'll show you in the code, where you can, it's not public yet, but market makers can go directly through the SDK. So we do have a few market makers currently using the SDK, but for now it's just for them, and then we'll open it up soon. I'll keep the glossary open in case there's any terms we want to go into, but maybe now's a nice time to dig into the code.
Let's do it.
Unless you had any questions before we go. Okay, cool, sick. So what I really like about this is it's a monorepo. It's charged by Turbo. So the database, the SDK, contracts, server, we use Subsquid as our indexer. And the front end, it's all here, both the website and the web app. So under apps, we have all these things. We have so I'll explain there's two parts of our Oracle that you asked about. The one is the calculator, and then there's a publisher. And then those feed into the Oracle contract. And instead of having our output from Solidity compilation go to just the outs in the contracts, it goes to the packages, which is our schema and our SDK. So if I go to SDK and SRC, then here's the ABI and addresses of the deployed contracts. So if I ever make a local change, it'll update the Foundry addresses, the Anvil addresses, and same for Sepolia and mainnet, which is really neat because then the front end doesn't have to find that and import it. It's just here, and then it's just automatically updated. The main contract is Silica pools, which is this one. I just want to show one thing first. So I was talking about how it's a monorepo. So we have all these scripts that you can run with Turbo. And if you haven't checked out Turbo, if you want to build a monorepo, I'd really recommend it. So I can do things like seed the database from the root directory, or I can run the whole app, everything with this command. This cleans your local stack, and then you can seed it again. Or I can just run the contracts, and then that deploys to Anvil and runs a local Anvil node for testing. We can also do tests and things here. Back to Silica pools though, I think. we have in our foundry.toml, it's 8.20. So even though it says that here, it's setting it to 8.20. And then these are all our imports. It uses library pool mats over and above the interfaces and contracts I've shown you, which I'll show you later. That's just our calculations for the pools. Yeah, so it's and a pool. So essentially, a long order is a set of two 1155 ERCs, where the one, well, like an order. So if I take the long, I'll have the one NFT, and then you'll have the short NFT. And then when we settle, we burn those NFTs and get out our corresponding wrapped BTC that's accrued over the time. These are just our type hashes. This salt is for creating the token IDs of those NFTs. The fee is 0.01% of the collateral, which is done in basis points. So it's 10,000, and then you'll see later we divide like 100 over 10,000. Yeah, some mappings, we'll get to those. So we have, let me actually open also the interface, because our structs are in the interface, and so is most of our NAT spec. Wait, that's the index. Cool, so over here, we have the interface.
Quick question, Tamara.
It's doing that infamous thing where, yeah, sure.
So do I understand this correctly? So if I'm not super familiar with derivatives or options protocols, but if I want to open up a long position, I need someone else to take a short position, right?
Sorry, after you said short position, you cut out.
Yeah, if I want to open up a long position, I need someone else to take the other side, right? Someone else to take a short position. Isn't that super hard as a market maker to do?
Yes.
Okay.
So you could take out both yourself, and be covered either way, or you make an order that's, so if I go back to that graph, I'm not going to make a long order that's going to always like settle long. So I wouldn't go for the floor and then make a long order, because no one's going to take that order on the other side as a short order. It has to be appealing for both parties. So there's some game theory there. Yeah,
Okay.
good question.
Okay. Cool.
So we have events, errors, pretty standard. And then we have two structs for a pool. There's the general parameters, which are set on when a pool's created. So the floor is the base, and then the cap is the top. The index, so what underlying asset we're tracking. The target start time, stamp, and end time. And then the payout token, which in our case right now is WBTC. And then once a pool gets initialized, so there's the pool creation, which is done off chain, or through the front end, and then there's the pool start, which is done by those cron bots I mentioned earlier, which if we have time I can show the code for. I had so much fun making those actually. So once we start a pool, then you actually initialize its state. And it's the state is the collateral minted, which goes up as more long and shorts orders are made. The shares minted, which is the number of NFTs. The index shares and balance, so that's the starting balance of the oracle when the pool was created or initialized. And then we'll check that again at the end and see who won the bet, basically. Was the long or the short successful? The actual times it started and ended, and the balance change per share, which is calculated by the pool maths library, and that's the actual what change was made. Then we have order structs, which I'll get to in a bit. Cool. So yeah, constructor. These are the owner functions. The silica pools interface has the NAT spec, but we can set the full fee basis points, but it's capped at a max. So it can never be more than, I think, 50%. So we can't ever take a fee, I think 50%. I can check, but so we can set it higher or lower, but we can't ever like rug the users and take all their collateral. Then the treasury address, bounty grace period. So our bot starts and ends pools at UTC 0, but if someone else made a pool that starts at UTC plus 10, then if another we want to open up our bounty, our starter bots and ender bots, and there's a bounty for that, and the grace period is how much time before you get a bounty for initializing the pool. So, for instance, the pools that start at UTC 0, right now it's set at 5 minutes. So I make sure that those pools are started within 5 minutes so we don't take a bounty from the collateral. But if I waited 20 minutes, I'd get a small amount of bounty collateral, which is the bounty increase per second. So if someone waited 20 minutes to settle a pool that was not settled by us, then they would get a bounty. But so the longer they wait, the higher bounty they'll get of the collateral. It's also capped at a max fraction. But if they wait too long, someone else will settle it before them. So you can start multiple pools at once, and this is called start pool, which is where everything starts. So maybe we take a look there. Cool. So pools are represented by a UUID in the backend, but in the smart contracts, it's a hash, which is a hash of a Kitchak of the pool parameters. And then we now create the state struct. We get the index, and we make sure it's time to start the pool, and we make sure the pool hasn't already been started. We then set the actual the start timestamp. We get the shares and initial balance from our index contract, which is our Oracle contract, which I can either show now or later as a separate contract. I don't know what you'd prefer.
Yeah, let's do it later.
Okay, cool. Then we calculate start bounty. So this is if the grace period is passed, you'll get some bounty amount. So it takes in the pool parameters as call data, and then it looks at how much collateral is in that pool and calculates the fraction of that collateral that you'll receive as a bounty, which in our case is always 0. But if someone else started a pool that we haven't started, or if our cron bot failed and you started the pool, then you will get a fraction of the bounty. Oh wait, that's end pool. Here's start pool. Cool. Then you minus the bounty amounts and transfer it if someone's getting a bounty, and you emit the event. Otherwise, you emit the pool started event, and now the backend can populate the pool with its actual shares and index balance and all the parameters. And then conversely, at the end of a contract, we have the end pool, which just basically does the opposite, but it calculates, so it gets the index balance at the end and the balance change per share, which is what we're betting on. So if I say, if there's a floor and a cap and I say I want to long the middle and I think it's going to go up, if the balance change per share is anything above that break-even point that I chose, then I won the bet. So this is seeing if it went above or below that target value, which is calculated in pool maths. We can look at that in a bit. And then same with ending pools, we have a bounty and we transfer, and then we emit the end pool parameters. I'm just going to go back up to external functions. Sorry, there's a lot of functions. These are views. Cool. Then you can, so you create orders only through the front end for now. And once an order is created, I can collateralize mint the the tokens, the NFTs, the 1155s, long and shorts myself straight through the contracts, or I can fill an order. So then what that does is it calls fill order, and that's when so you made a short order, and then I'll fill the order, which means I take out the corresponding long version of it, and only then does your collateral get transferred. So maybe we take a look at full order. I just want to see what other functions are here. Or redeem at the end. We can get to that in a bit. Full order. It's here. This is where everything really happens. So an order is created with a signature, and we verify that that signature was made by the maker of the order. The fraction we want to fill is 1e18, so that means in this case we're filling the whole order, so we can't do a partial fill here. We check if it's not cancelled, and then here we do a ECDSA recover of the hash and the signature, and we make sure that it returns the order maker public key. Usually when you create an order, you make the taker address 0, so anyone can take it. Otherwise, if you want to do a private order between just us, then you can say order taker is OX whatever, and if that's your public key, then you're allowed to fill the order. Otherwise, it's an invalid caller. We check the order's not expired, and that so in an order, I have offered long shares and requested long shares. So let's maybe look at that order struct that I had over here. So the maker, the taker, 0 address if public order expiry, offered upfront token and amount. So I can offer an upfront amount and request long shares, which in that case I'm making a short order. Or if I don't have an offered upfront amount and then I've offered long shares, and then I'll request an upfront amount from the taker of the order, and that's a short order. So then for now, these are usually equal, the requested long shares params and offered long shares params. But you could also later on do things like you could request between two different types of underlying assets, but that gets quite complicated, so we won't go there yet. Cool, so once we've done all our checks, we start with our FX. So only now that you're filling my order, the long side pays the upfront token amount as the collateral to the short side. So that's a safe ERC20 transfer. And one of these will be non-zero. So it's a transfer of collateral happens from the long side. Then we mint the ERC 1155s. The collateral is calculated in the pool maths library. I'll bring that up in a second. It's just some maths, really. So only on full order does the taker pay a fee. That's the only place we take a fee. And that's calculated as a surcharge over and above the collateral, which is now 0.01% of that collateral. So it's collateral times the basis points over the inverse basis point, which was a constant of 10,000. And then we transfer that from the taker, who's obviously the message sender because it's the one filling the order, to the treasury and the surcharge amount. Then we now get the token IDs. So this short token ID just takes the order and that salt and creates a hash. And that'll be the token ID for the short 1155. We emit an event. Then we do a collateralized mint. So now the maker is paying the collateral. This collateralized mint is just mainly a transfer of collateral from the maker to this contract. Then so now we see if it's a long or short order. And we do the same thing. That's just the inverse of what we saw above. Then we emit, we were getting a stack too deep because we had too many things to emit, so we broke it up into a few events. So a trade history event, I don't know if you remember, there was a trade history page on the UI. So that's all of this information here, the order hash, the order maker, the order taker, which is message sender, the hashes of the offered and requested long shares parameters, and then the index, the fraction filled, and the fraction remaining. And then and then this is just if it's, so I'm offering long shares and I'm requesting an upfront amount. So this is for long orders. We emit a volume accounting event, which is just all the information about the long order. Otherwise, if it's a short order, we just emit this event. And then that's how an order gets filled. So your collateral only gets taken by to the contract when someone else fills your order. So if no one fills your order, your collateral stays with you. So you don't have to transfer it and then redeem it later and just pay gas fees and no one took your order. At the end of a contract, then you can redeem, this one's redeem long. There's also a redeem short, but they'll be the same. We get the pool hash from the parameters we pass in as call data. We get the token ID, and we make sure that there's a balance. I have the token ID. These tokens are obviously transferable because they're 1155, so I can also trade these positions on secondary markets or directly to another address. We calculate the payout, which is the balance. So for a long order, it's balance change per share minus floor times collateral minted of the whole pool over cap minus floor, the whole range of the pool, times how many shares I have, which is those NFTs, divided by the total shares minted. And you might ask, why do we times and then divide, and then times and then divide? Because usually in Solidity, you want to divide at the end of all your multiplication. But we found that this gives a much better precision for tokens with smaller decimals. So if we were saying USD is the payout token, and you only have 6 decimals, or if we did some random like shitcoin of the week as our underlying asset or our payout token, then we get better precision this way, as opposed to the rounding issues. We did like a week worth of fuzz tests to check that the precision loss was so negligible from timesing, and dividing that we did this, which is, it doesn't follow a Solidity convention, but for this protocol, it makes sense in this context. We then burn the tokens, the NFTs, and we transfer the payout of the long position holder, so that they would click claim on the UI to do this, or they would come straight to the contract on Etherscan, and then we emit the shares redeemed event. And we have the exact same thing for redeem short, but the payout is different. So instead of being balance change per share minus floor, we now have cap minus balance change per share times collaterals. Everything else is the same, but instead of being balance change per share minus floor, it's the top minus what the actual value was at the pool end. So you can only redeem short or long tokens after a pool has ended, which we check here. So the actual end timestamp is set on end pool. So if that's equal to 0, the pool hasn't ended yet, you can't call this function. You can refund your collateral if you, let's say you make a long order and you're like, oh, I meant to make it differently, or no one's going to take this order, I want to make a different order. Then you can just do a collateral refund, and it just burns those tokens, settles you, and settles your position, and gives you your collateral back, and basically cancels your order. Yeah, it calls cancel order as well. These are all pure functions, so they just, yeah, this is how we create the IDs. So this isn't that interesting. And that's actually the meat of the Silica Pools contract. I think what would be great to look at next is either the Oracle or the pool maths. I think maybe the Oracle, if that's cool. So we call it an index. Okay, cool. So the Oracle calculations are done off-chain and fed daily at UTC-0 to this contract. So yeah, some name, symbol, decimals, and balance token. So this is WBTC. This will be the decimals of WBTC, and then the name and symbol of this this index. So it'll be different per underlying asset. There's 2 events for when we update the balance and shares. So there's no mapping of like on this date this was the shares and balance. It's always today, and then when you call end pool, it just pulls from that, or start pool. So it's a pull-based oracle, not a push-based oracle. Errors. We use access control for roles. Cool, just some requires, and then grant some roles. So the first thing we have is a sorry, I'm going to skip this and come back up. We have a calculator. Oh, the calculator is done off-chain. So we have a calculator role, and that's our off-chain oracle that does the RPC call to the Bitcoin network. And it then signs a message with a signature and publishes that as the calculator. Then we have another role or address that can then take those values. It does some accounting to make sure those calculations make sense. And if they make sense, then you can publish. So that one address, or whoever has a publisher role, can then set the balance and the shares of this index. And we make sure here that the message hash matches that of the calculator. So if you came to our oracle and you tried to update the balance or the shares, you can't because you don't have the calculator message. So you'll fail on this signature here. Yeah, that's basically how it's done. And then you can set shares. Yeah, and then these are just view functions. So it's quite a simple pull-based oracle system. We might one day make it a push-based and have a mapping of timestamp to shares and balance. But for now, the pull-based works because we only need these values when we start and end a pool, which is taken from the Silica pools. Then we have the pool maths. So this is how collateral is calculated. We use the fixed point math lib from Solidi because we want to round up or round down depending on if it's long or short. And then this calculates the short payout, which is, I've already explained, it's that cap minus balance change per share, which is the actual value, times collateral minted over this. So we've seen that actually. It's just calculating that. Same for long payout, but balance change per share minus floor instead of the short payout version. This takes the gross balance change per share, which is the total balance change per share, which is the total change of the median transaction fee. And then that is fed into balance change per share, this internal function. And it just takes, so you either take, if floor is the max, then you just return floor. Otherwise, it takes the min between cap and gross balance change per share. So in most cases, it turns the actual gross balance change per share. But if that was floor or cap, then it returns either cap or floor. Yeah, and then this just calls that. It's just the internal wrapper. Yeah, and then we have min and max. So that's the library. That's everything basically. It's quite a simple. I think because we're on version 3, it's been simplified a lot, and this idea of putting everything into one pool has really simplified our architecture. But in version 1, it was like 5 or 6 contracts as opposed to just the 2. Lots of tests, and then our scripts are done in shell script, which I've really enjoyed. So like, let's say we want to fill an order, then we'll have like all these variables, and then we do costs. So this is for local testing. We do cost commands to call Anvil and yeah, call the functions with their selectors.
Interesting. Why not forge scripts? Do you get some off-chain data
Good
and stuff?
question. So forge scripts are nice. Yes, this is to get off-chain data, and it's also nice because it writes to our packages here, and then the front end packages, SDK, SRC, ABI and addresses gets updated automatically. So and it can use the utils here. So it just lets us. It's because of the monorepo. But for end-to-end tests, which I don't have in this version, we did use Solidity scripts just for pure contract tests. But we found the shell scripts are great for the monorepo because you can write to this directory, or you can pull this function from the utils of the SDK. We've got a bunch of utils here in TypeScript.
Interesting. Talk more about the monorepo.
Yeah.
Do you like the setup,
How are we doing for time?
or do you like to put contracts in another repo? Yeah, what's your opinion?
Oh, sorry, you broke up again. Were you asking why a monorepo?
Yeah, I was asking if you like it personally.
I do. At first, I was like, "Ooh, why are we doing a monorepo?" I'm used to just working on contracts.
Yeah.
But now I like it because there's so many turbo commands here that I can do anything. So I can see how my contracts are affecting the database or the server or the front end, and then I can run the front end locally, click on the front end, and see in the GraphQL playground how my contracts, what events they emitted. So it's nice for like full stack testing, and it makes it much easier for the backend and front end developers to integrate with the contracts because it's just automatically updated in packages over here, and then they just pull from that. Which I know in the past at some other companies I've worked at, you have to send the ABI manually, or the front end engineer has to go to the contracts repo, find the ABI, copy it, paste it, move it across. Here it's just pulled in automatically. So it's really neat.
Okay.
But it is quite like a lot, and it was a lot to learn turbo and stuff, but it's fun. So like if I go if I do something like this deploys the whole app, backend, server, the cron bots, everything, front end, contracts, all at once. It's quite a lot to watch, but it's really fun. So that's deploying to Anvil. Now we're doing the subsquid. That was the indexer. Now we're doing some local testing on Anvil. This is the publisher publishing some data to that indexer contract. Now we've got subsquid, and subsquid's ready, and now it's ready. So I could click on the front end, make an order, and etc. And then I can test how things are going.
Okay, that's
I'm
pretty
gonna close
nice.
that though. But this is really fun, just like building a whole app in one command.
Yeah, that's pretty nice. What about onboarding new people? Like onboarding a new smart contract person, for example.
We have quite extensive documentation internally.
Hmm.
We have quite an extensive Notion documentation. and all new features in the smart contracts were first, so because it's called silica pools and silica this and silica that, we have silica improvement proposals. We call them simps. So if someone new joined the team, they can just read all the simps and see how we started, like the fee mechanism changed. So they could see how it was, and then see the proposal to change it, how it was ratified, what was changed, and then come and look at the code. And we have a lot of NatSpec in the interfaces, and then we have a lot of internal Notion docs. So that's how we would onboard. And then also just in-person sessions.
Nice. What about onboarding as into the monorepo? Like I feel like, okay, you ran this turbo script and it ran everything. I feel like, okay, if I don't know, I think you're on a Mac now. I think if I'm on Ubuntu and something in the middle totally breaks, probably the debugging isn't that super easy. Or I'm on Windows or something.
Yeah, that's a good question. I think our whole team is definitely Mac, so I'm not too
Okay.
sure. Um, but Turbo does work on Linux machines. Um, and then maybe if there's an error, we could just update the turbo.json. Um, and then it's quite easy. Once you've just read the turbo docs, you can just look at these scripts and say, oh, what I want to do is I want to build, um, or like cogen, and then you see where that comes from in this turbo.json. So even in the contracts, there's a turbo, no, it'll be under package. So these are the scripts that the turbo.json, the packages, sorry, these are the scripts that get called by the scripts in the root directory of those turbo scripts. So if I say build in the root directory using turbo, then it calls build here, and then it just says forge build, and we have it via IR off just for local testing. Um, but when we do build production, then via IR is included. And then you can deploy Sepolio or like dev. So dev all calls the dev function in the dev script in every single app and contract.
Mm.
So it's not actually too much to learn because it's all just you just see these scripts.
Nice, nice, nice. No, having everything set up in one command is pretty sweet. Like on Diet right now, when I want to set up a testing environment, it's quite involved, to be honest. Like it takes a lot of step. Having that automated, I can see the value in that for sure.
Yeah, it
And
really
it's
does
all in my
simplify
head.
things.
It's like a
Um,
nightmare to onboard a new person. So, yeah, it's pretty bad.
I can imagine.
Yeah, yeah, yeah.
Yeah, that must
Yeah.
be a lot. Um, yeah, I'd recommend trying out Turbo. It's really interesting, and
Yeah.
we use it just for these scripts, but it does a bunch of other stuff too, and it can help with CI/CD in a big way.
Hmm. Yeah, right. CICD. Yeah, for sure. Awesome, Tamara. Listen, this was fun. Thanks for taking the time. Thanks for doing this. I'm gonna put the link to the repo. It's all open source, right? It's
Thank
all on
you.
GitHub. It's all on GitHub, I
Yeah.
think. Yeah, I'm
Um,
gonna. Yeah.
it's it's on GitHub and then it's also on Ethereum. So definitely the contracts you can check out on Ethereum. And the Turbo repo is about to become public.
Awesome. Then I'm gonna put the docs in the description down below. I'm gonna put your Twitter in the description down below. Tamara, this was fun. Thanks for doing this.
Thank you. I had a good time. Hope you have a good day.
Awesome, guys. Thanks for tuning in, and I'll see you in the next one. Bye bye. Yeah, thank you, Tamara. Sorry, it's I'm in